So starting with the pop quiz one, which is related to Unit 1 and Unit 2 topics. The first question is related to acceleration due to gravity. A student carried out an experiment to measure the acceleration of a free fall. So student is finding the acceleration due to gravity or acceleration of a free fall. A ball bearing was released at the position A, and the time for the ball bearing to fall a distance L is measured. This was repeated by decreasing the value for the L. Explain how the measurements obtained can be used to determine the acceleration due to gravity. Your answer should include the sketch of the axes below. So what are the variables which we measure? We measure the distance here and we measure the time interval. So whenever we need the acceleration due to gravity for a falling objects, we can use equation of motion. So we have three equations of the motion, like we four are there, but it's like related, all are related to each other. So we have V is equals to U plus AT. We have S is equals to UT plus half AT square. We have 2AS is equals to V square minus U square, and we have S is equals to U plus V divided by 2 multiplied by T. Now, with reference to the experiment, here we are measuring a length. So length means the distance we are measuring, and the timer is there, so we are measuring a time. So we want the equation in which we are measuring S and T, and we are finding A. So this equation cannot be U. And what about U? Because when object is released, when object is dropped from a certain height, so the initial velocity is always 0. So we already know the U, the value of a U is also known, which is 0 here. So what about the first equation? We don't know the final speed. We know the initial speed, which is 0, and we have the time. But here we'll have two unknown, like we'll have acceleration unknown and velocity also unknown. So we cannot use this first equation. What about the second equation? We have we measure the S by using a scale, a ruler, or a meter rule. U is 0. Time we measure using a timer. So we can work out this equation. It means this equation is valid because only one unknown is there. So we have this equation, S is equals to UT plus half AT square, where U is equals to 0. So if U is equals to 0, so S is equals to 1 by 2 AT square. So S is actually the distance. So we can compare, like we can change this equation. S is actually equals to the distance L. 1 by 2 acceleration is due to gravity. So we can say G and T square. We can compare this equation with the equation of straight line, which is Y is equals to mx. So on y-axis, if we sketch L, and on x-axis, if we sketch t square, it will start from origin because there is no y-intercept. So this will be a straight line which is passing through the origin, and the gradient of a straight line is equals to half of the, because this will be g, the gradient will be equals to half of the gravitational field strength or free fall, or the gradient multiplied by 2 will give us a value for gravity. So you have to mention, like, we'll use like 1 mark you will get when you mention using an equation S is equals to UT plus half AT square, in which the initial velocity is 0. The second mark you will mention that we will measure the length by using a ruler scale, and the timer, we just use the timer to record the time interval. Then we'll plot a graph between the length on y-axis and the time square on x-axis. The gradient of the graph will be equals to half of g. So g is equals to twice of the gradient. And it will be a straight line which will pass through origin. So these are the parameters, like mentioning the equation, mentioning what you sketch on x-axis and which quantity on y-axis, and then what will you will predict what will the shape of the graph. It will be a straight line because the gravity is constant, 2 is constant. So it means the gradient will be constant. And it will start from origin as well. Why we say it will start from origin? Because there is no y-intercept. Is it clear, this one? How to work out the acceleration due to gravity? The next question is related to the standing wave experiment. An experiment is carried out to investigate the speed of transverse waves on a stretched string of length L. A vibration generator causes a string to oscillate. First, why this pattern is produced? So, why standing wave is produced? When two progressive waves traveling in opposite direction, this will give rise to the standing wave. So these are the two progressive waves which are moving in opposite direction, give rise to standing wave. And as a result, when it produces a standing wave, so it produce nodes and antinodes. Nodes are the region where they cancel out, and antinode where they increase the effect of each other. Determine the wavelength of a wave on the string with the vibration shown length. So how to determine the wavelength? The total length is there. The distance between the two successive nodes is half a wavelength. So this is node. The two successive nodes is half a wavelength. Like example, this distance is half a wavelength. This distance is also half a wavelength. This one is half a wavelength, and this one is also half a wavelength. So it means like this is one complete wavelength. This is like one wavelength. Three successive nodes equals to lambda. Three successive nodes equals to lambda. So means this total length is equals to twice of lambda. So the total length is equals to twice of lambda. And if we need a lambda, so lambda is L divided by 2, where L is a total length 1.7 and divided by 2. So the each will be 0.85 meters. That will be the wavelength. So it depends on the pattern. According to that pattern, we worked out. Calculate the speed of a wave on the string of mass m, and the mass per unit length is given. So the formula to work out the speed of a wave in a string, there are two formulas you can use. One is the wave equation in which v equals f lambda, and the second is v is equals to under root t divided by mu, where t is the tension and mu is the mass per unit length. Like how much force is applied, what force is stretching the spring, that is called a tension. And that tension is equals to the weight which is attached here. So the mass is 0.2 kg. So mass is 0.2 kg. We multiplied by gravity 9.81. This will give us the weight. So weight is actually equals to the force on the spring, the force which is stretching the spring. Why we do not use V equals F lambda? Because we don't know the frequency of this generator. That's why we will use V is equals to under root T divided by mu. Both formulas are valid depending on what are the parameters given. So T is a tension. And mu is the mass per unit length. So V is equals to under root T, the tension, which is the mass, 0.2 multiplied by gravity 9.81, and mu is the mass per unit length, which is 4.5 into 10 to the power minus 3. So when you divide this, you will get the answer in meter per second, which is about 20.9 meter per second. This question is related to Unit 1, motion topic. A Saturn V rocket used in NASA space program has a mass of 3.04 exponent 6 kg. It took off vertically with a thrust of 3.4 exponent 7 Newton. What is the resultant force? So what is the resultant force on the rocket? There is a thrust and the weight of the rocket is acting downward. If we need the resultant, so what we have to do? The resultant force will be thrust, because the rocket is launched, so it means it will accelerate upward. So thrust minus the weight. That will give us the resultant force. So you can use a resultant force F, or you can also use sigma F, which also means the resultant force. So the thrust is given, which is 3.4 into 10 to the power 7 minus the weight of the rocket. The mass of the rocket is 3.04 into 10 to the power 6 times the gravitational force, 9.8. So 38.04 exponent 6 multiplied by 9.8, that will give us the resultant force acting on the rocket. Now, why resultant force is the thrust minus? Because the rocket is propelled. Rocket is launched upward. So because it is launched upward, so means upward force should be greater than the weight. Rocket is not moving down. If the rocket was accelerating down, then if we need the resultant force, we'll say weight minus the thrust in that case. Or for example, if the rocket is moving down, and because the thrust is the force which is from the engine, so if the thrust is also acting down and the weight was also acting down, so in that case, the resultant force will be weight plus the thrust. Because the rocket is launched, that's why the thrust, the force of the engine will be more than the weight, so that the rocket can propel. Then calculate the initial acceleration. So how to work out the acceleration? So when we work out the resultant force, like this is the resultant force, answer should be close to this. And if we need the acceleration, so resultant force is equals to ma. So resultant force divided by mass is equals to it. So we have the resultant force and we have the mass also of the rocket, and we get the A. But usually what happens for the rockets, the acceleration is not constant. Why even though the resultant force is constant? Because what will happen, the mass of the rocket will decrease because rocket is burning the fuel. So as a result, the mass will decrease. So when the mass of a rocket will decrease, its acceleration will increase. Is it clear, this one? Which question is related to DC electricity? A cell with an EMF of 1.5. So we have a cell with the internal resistance. So the EMF, the maximum potential, is 1.5. The acceleration is the resultant force divided by the mass, you will get the acceleration. Resultant force, your answer for the previous part, divided by the mass, that will give us the acceleration of the rocket. We need the internal resistance R. The lamp is there, which is 80 ohms, and the current is 17 milliampere. Milli means 10 power minus 3 or 17 divided by 1000. So we have the formula, the total EMF is equals to voltage drop external plus the voltage drop internal. Voltage drop internal is IR and voltage drop external is V. Or you can change the order, it does not make difference. So the total EMF is 1.5. What about the external voltage? Because the external current is 17 milliampere, so 17 exponent minus 3, and the external resistance is 80. So it will be 17 into 10 to the power minus 3, because we need a voltage here. So voltage is the product of current and resistance. So 17 into 10 to the power minus 3 times the current, which is the current is 17 exponent minus 3 times the resistance, which is 80. So this will give us a value for voltage. Then this is also 17 into 10 to the power minus 3, and internal resistance we don't know. So this factor will go there, subtract, and then divide it. So it will be 1.5 minus 17 into 10 to the power minus 3 times 80. And this divided by 17 into 10 to the power minus 3. This will give us the value of internal resistance of this cell. which is 8.235. So write your answer always in 3 significant figures. So we'll write as 8.23 ohm. Question 5, which is related to Newton's law. What is meant by the Newton first law of motion? So according to Newton first law of motion, the statement we need. So according to first law, if an object is moving at a constant velocity, it will continue to move with the constant velocity. Or if an object is stationary or at rest, it will continue to stay at rest until unbalanced force act on it, or there is no the resultant force on the object is zero. So the object at rest remains at rest, or object moving continue to move until unbalance or a resultant force act on it. And Newton's first law is also known as the law of inertia. Newton's third law identifies the pair forces, like forces always acts in pair. Two ways the pair forces are identical. So they are the same type of the force. They have the same magnitude. The pair forces, the similarity. They act in the same time, act on the same line. These are some similarities, and how the pair forces are different from each other. The direction of the pair forces are always different. Like example, if there is a downward force on the surface apply an upward force, but they act in the same line. So the directions are different, the direction of the pair forces, and the objects on which the two pair forces, like pair forces acting, that is also different. Like example, if we push the ground will push us. So means our force is on the ground and the force of the ground is on us. So that's why the Newton pair forces are always acting in different directions of and acting on two different objects. That's how they're different from each other. This question is related to the Doppler effect, means the relative change in frequency or the wavelength as the object is moving towards or away. A siren of an ambulance emits a sound of a certain frequency. As the ambulance passes the pedestrian, the frequency of the sound he hears changes. State the state name given to this effect, so we call that as a Doppler's effect. Because what will happen, like if a source is moving towards the observer 1, he will receive a higher frequency or a shorter wavelength. And if it is moving away from observer 2, it will receive a shorter frequency and a longer wavelength. But remember one thing, the frequency of the source is not changing. Source is emitting the same frequency, but because of the relative motion, what we receive will change. So describe and explain how the movement of the ambulance causes the frequency of a sound he hears to change. So when the ambulance is moving, how the frequency will change? So what will happen? The same idea as if the ambulance is moving towards the observer, then he will receive more radiation or more waves per second. So the frequency will increase or the wavelength will decrease. And opposite will happen if the ambulance is moving away, and less waves per second or the frequency, or you can also say for a sound, you can use the term pitch. So the frequency will decrease or it will have a lower frequency and the longer wavelength. You just have to mention, describe and explain the movement of ambulance cause of frequency of a sound he hears to change. So that you will mention if it's moving towards higher frequency, shorter wavelength, moving away, higher wavelength, shorter frequency, smaller frequency. So this was the pop quiz 3.